Hello students, good morning to all. Welcome to the channel Firjan. See, today we discuss electrostatic and potential. In this lesson, fifth video, potential in concentric cells. So before we would discuss electrostatic potential due to spheres. So hollow conducting, hollow non-conducting, solid non-conducting, everything we discuss. So in this one we discuss potential in concentric cells. Before going to discuss this one, some basic point. What is now first now here we can take sphere. It is the conducting sphere. Charge is resides on surface of the sphere. For conducting sphere, charge resides on surface of sphere. Due to this sphere, see, or distance from the center, outside point, what is the potential? That we can write here. This point, what is the potential? So, K Q by small r. That is the potential. So, means outside point, potential outside or distance from the center. What is the potential now? KQ by small r. So, that is variable this one. So, according to distance it changes. See, same due to this sphere from center or distance inside point, what is the potential now here? See, potential inside is kq by capital R, means it is constant, not changes. See here, from center up to surface, potential maintains constant due to conducting spheres. Due to conducting spheres, solid non-conducting, that is different. For conducting spheres from center to surface, so kq by capital R, so it maintains constant potential from center to surface. Outside surface, it is variable. So basing on this, we can do here potential in concentric cells. Here two concentric cells is there. First cell radius is Ra, second cell radius is Rb. So charge is Qa, Qb. See here what we find out now. Here find electrostatic potential on surface A and surface B. We want to find out what is the potential on surface A, what is the potential on second surface. See, first we can write potential on surface A. What now here? Due to this potential on surface, due to two spheres is there. One is this one, Ra and Rb. So Qa, Qb. So due to means potential on A due to Qa, potential on A due to QB, due to QB. See here, due to QA on surface point. See, on surface. See, this is the, here we find out potential. So this point or this point, any point on this surface, what is the potential now? Due to A. So mean it is on surface. So mean on surface, what is the potential that we can take? See, for this one, due to QB, due to QB, it is inside point. It is inside or distance. So inside point. So what is the potential? See, from center to surface, potential inside point. What is the potential now? KQ by capital R. Means here for this sphere, it is inside point. On surface A, we find out potential. So that's why what is the potential on surface A due to outer sphere na? From center to surface maintain same, but radius we can take this one. See here, from center to surface, potential inside point is constant kq by r, but radius we can take capital R only. What is the radius of this sphere? That we can take. So here for this on surface A, we want to find out what is the potential on surface A due to surface B, means radius we can take Rb, inside point from center to surface same. So that's why it is inside point. We can write inside point na, outside radius, charge is outside, it maintains constant from center to surface. So that's why we can write potential on surface A is potential on A due to QA. So charge is K QA by on surface means radius RA. It is the potential on A due to QA charge. Potential on B due to potential on surface A due to QB. So means KQB by RB, inside point from center to surface, same potential. That's why we can take this radius, outside radius we can take. outside sphere radius we can take aq by rb. This is the potential on surface A. Again listen, potential on surface A due to here two is there, one is qa, another one is qb. Due to qa on surface point, due to qb inside surface point, inside surface. Due to this one qb, it is inside point, so that's why q2 due to eqna kqa by ra, due to qb kqq by rb. See now here potential on surface b, potential on surface b. See I write here potential on b due to qa charge and potential on b due to qb charge, qb charge. See here due potential on b due to qa, it is outside point. qb due to qa, potential on qb what na outside point. Potential on qb due to qb na, potential on b due to qb is on surface, it is outside point, it is on surface, on surface. Right here potential on b due to qa, kqa, it is outside point. Outside point means we can take radius rb, so rb plus potential on b due to qb means k qb, radius is rb. It is the potential on surface B. See, potential on surface A means potential on A due to QA plus potential on A due to QB. QA means on surface, QB means inside surface. So we can write KQ by RA, KQ by RB. See, potential on B due to QA, due to QA, potential on B outside point. So potential on B due to QB on surface. We can write VB equal to KQA by RB, KQ by RB. It is the potential on surface A and surface B. Next see potential, find potential on surface B and surface C. Three concentric circles they give. Three concentric circles. See here, it is the first sphere, it is the second one, it is the third one. See here, its radius is r, its radius is 2r, its radius is 4r. Charge on first sphere is q, second sphere is 2q, third sphere is 4q. See, find electric potential, find electric potential due to, find electric potential on surface B and surface C. Surface C. This we want to find out. See here, three concentric spheres is there. See for this first one, this is the first surface, second surface, third surface. Radius is r, 2r, 4r, charge is q, 2q, 4q. What we find out here, potential on B. Potential on B equal to what we can write, potential on B due to first surface means due to q charge. Potential on B due to, potential on B due to 2q. Potential on B, potential on B due to 4q. See here, potential on B surface, potential on B surface due to q, q na outside point. See due to q outside point, due to 2q on surface, due to 4q inside point, due to 4q inside point. See here, potential on B, it is the A surface, B surface, C surface. Potential on B due to q na inside point, potential on B due to 2q na on surface, potential on B due to 4q na outside point, sorry inside point, it is outside. Now I write here potential on B. See potential on B due to q, due to q na outside point, outside point means radius 2r, we can take charge q. So means k q by 2r plus potential on b due to 2q na on surface. So radius is 2r, charge 2q. So k 2q by 2r plus potential on b due to 4q means it is out inside point. What is the radius of 4r? See, potential on b due to 4q, it is inside point, radius is 4r, we can take. So means k 4q charge, radius is 4r. See here, two twos we can write, denominator same. See, I write here potential on b equal to kq by 2r, we common, now what we get here? 1 here, 2 here, 2 we get. So what now here? Potential on b equal to kq by 2r, 2 plus 2 4 plus 1 5, 5 kq by 2r. It is the potential on surface b. Again listen, potential on surface b means due to q, due to 2q, due to 4q, due to q outside point, 2q on surface point, 4q inside point. See, on surface b due to q means outside, so charge is q, radius is 2r, we can write. Due to 2q on surface, radius is 2r, charge is 2q, here 2q by 2r. Due to 4q, radius is 4r, inside point, charge is 4q, k 4q by 4r, 2 twos, 2 twos. See here, kq by 2r common, here 1, here 2, here 2. What we get? 2 plus 2 4 plus 1 5 kq by 2r. What is the potential on surface b? Potential on surface b equal to 5 kq by 2r. It is the potential on surface b due to q, 2q and 4q charges. See, potential on surface c, what now here, right? Potential on c due to q charge, potential on c due to 2q charge, potential on c due to 4q charge. See here, potential on c, this point, due to q, inside point, I write here inside point. Potential on c due to 2q, inside point, c inside point. Potential on c due to 4q, on surface, on surface. So means, see here, this also inside point, this also inside point. So from center to surface, potential is same, that's why we can take radius 4r. See here, right here, potential on c due to q, kq, radius 4r. Potential on c due to 2q, q means 2q, k 2q by 4r, radius is 4r. Potential on c due to 4q, k 4q, radius is 4r. See here, on surface C, what is the potential na? Due to Q, one potential, due to 2Q, one potential, due to 4Q, one potential, due to Q, inside point, due to 2Q, inside point, due to 4Q, on surface. So, but here center to surface, same potential, that's why we can take this radius. See here, KQ by 4R we can common na? What we get here? Here 1, here 2, here 4. What we get? 4 plus 2, 6, 6 plus 1, 7. What is the potential now? 7 kq by 4r. What is the potential on surface C due to q, 2q and 4q now? 7 kq by 4r. 7 kq by 4r. It is the potential on surface B is 5 kq by 2r, surface C 7 kq by 4r. Now see, potential, now we discuss earthing. See, earthing means what? How the potential changes, charge changes, that we discuss. See, earthing. Earthing means connect any conductor any conductor, see, connect any conductor, connect any conductor to the earth, its potential is zero, potential is zero, called earthing. See, potential on conductor due to earthing, what is the potential now? Zero, but charge need not be zero, charge need not be zero. See here, earthing means connect any conductor to earth, its potential is zero. See, in this case, potential on conductor is zero, but charge need not be zero, charge need not be zero. See here, we can take for example here, it is the first sphere, its radius is r, another one here, see this one, its radius is 2r, radius is 2r, here charge is q, sorry q here, here 2q charge is there, it is connected to earth, connected to earth. See what now here, potential on conductor is, potential on conductor is zero, but charge on conductor is not zero, charge on conductor is not zero. See, on conductor A not zero charge, only potential is zero, potential is zero. When connect any conductor to the earth, their potential is zero, but charge is not zero, need not be zero. Yes, no, it is the earthing. So according to this we can do the problem. What now, first one, see, right here, first sphere, it is the first sphere, radius is r, second sphere, it is the second sphere, radius is 2r, 2r, it is the third sphere, see, its radius is 4r, charge here q, charge here 2q charge, it is connected to earth, connected to earth. See here, here charge is, we don't know what is the charge, so we consider q charge is there on that one. Yes, na, see that q charge we can find out. See here, when conductor is any conductor is connected to earth, their potential is zero. Here what we find out now, after connect, after earthing shall be, find the potential, find the charge on shall be, shall be. See here, these are the concentric cells. See, first one radius is r, second one is 2r, third one is 4r. Charge on first one is q, charge on second one is 2q. What is the potential, what is the charge on second one? That we find out, that we don't know this one, so we want to find out. For that we can take q charge on the surface B. So we can take here, potential on B is what, earthing na, so zero, so we can take first potential on B, we can find out, later that potential will be zero, equate, we can get the what is the charge on the second surface. See, for that potential on B is zero, so that we can take first, we can find out potential on B. For that potential on B due to q, first sphere, potential on B due to second sphere, so q, potential on B due to third sphere, that is 2q. What now here, charge 2q. Now see, we can write potential on B due to q, due to q means on surface comparing with surface B, it is inside point. It is inside. Potential on B due to Q now, that is on surface. Potential on B due to 2Q now, outside point. Outside point. See, potential on B due to Q means charge is Q, radius is we can take second sphere, so 2r we can take. Why not? From center to surface maintains constant potential. See, potential on B due to small q, what is now here? K q by radius 2r. Why? Because on surface. Potential on B due to outer sphere, so means that is potential on B due to outer sphere, now charge is 2q, radius is 4r. Radius is 4r. See here, 2 ones, 2 twos we can write here. See, potential on B while earthing, potential is 0, so potential on B is 0. Why? Because it is earthing. Yes, na? So that's why potential on B is 0. Here we can take 0, so 0 equal to k q. So k by 2 are common na. See what we get here, q plus small q plus capital Q. See here, it's 2r changes to here 0, k also changes to here 0. So what we get, q 2q plus small q, that equal to 0. What is the small q now here? Small q equal to minus 2q. It is the charge on second surface due to earthing, but potential is 0. Like that we can find out potential on shell B after earthing. So what we can do now, first potential on B we can write. So potential on B due to q, potential on B due to small q, potential on B due to 2q. So potential on B due to q means inside point, small q means on surface, 2q na outside point. So like this we can find out what is the charge on surface B after earthing the surface B, after earthing surface B. Now see one more, two concentric cells, two concentric cells, two concentric cells connected through conducting wire, conducting wire, then find potential on each surface, each surface. We want to find out what is the potential on each surface after connecting the two cells with a conducting wire. So that is the problem. It is the problem. We solve this one. See, we can write here. So shall I erase this one? See, once we can take two concentric cells. See, it is the one, it is the one concentric cell. In this one charge is 7q, charge is what? 7q. Its radius is here, see, its radius is 2r. See another cell, it is another cell, it is the another cell, its radius is r, charge is 2q, charge is 2q. It is connected through conducting wire, connected with through conducting wire. See, this is the problem. See, radius is same, or its radius is 2r. It is connected through conducting wire. See, connected means switch is there, switch on now. What happened now here? Charge is distributed, so means charge is transfer. How much charge transfer here? We don't know. That we can write q charge is transferred, or we consider q charge is transferred. After transferring, what now here? See, this is the first sphere, so radius is r. This is the second sphere, radius is 2r. Here see, after connecting this with the conducting wire, yes, now what happened now here? Charge is transferred. Actually, what is the charge here? 2q is there. After transferring, it will lose some charge, that we can write 2q minus q. Here it went gains charge. So 7q plus q we can take. See, it is the surface A, it is the surface B. See, after conducting wire, what is the charge on each sphere we want to find out, or each shell we want to find out. See, before we know hollow conducting or non-conducting, solid conducting, all spheres charge will be resides on surface. So means here, see, in this case, when it is connected now, total charge will be resides on surface. So that's why from center to surface total charge is transferred from here to here. Automatically it will transfer. Why? Because conducting cell this is. So that's why charge will be transferred. Charge transfer means total charge will be resides on this surface. That case, from center to surface potential is maintains the same potential from center to surface. That's why potential on A which is equal to potential on B we can take. This is the condition. See, solid, sorry, hollow conducting non-conducting or solid conducting sphere. See what now here, when it is connected through conducting wire, charge will be transferred from this surface to this surface. That case, total charge will be resides on surface. So means here potential is same. Why? Because from center to surface potential is same. That's why we can take here condition potential on A equal to potential on B. Now we can do what is the charge on surface A on surface B. After finding q value, we can find out what is the charge on each cell. So for that, what we can do now, potential on A. Potential on A means due to this one and due to this one. See, potential on A due to 2q minus q, 1. Potential on A due to potential on A due to 7q plus q, that equal to potential on B due to 2q minus q. Potential on B due to 7q plus q. Yes, na? This one. See, potential on A due to 2q minus q. Potential on A due to 7q plus q. Potential on A due to 2q minus q. Potential on B due to 7q plus q. This case, see here, potential on A due to 2q minus q. What na here? K 2q minus q, it is on surface. For this is outside. See, for this, for potential on surface B, for finding what is this point, inside point. Yes, na? It is on surface. See, 2k 2q minus q by on surface na, or radius. See, potential on A due to 7q plus q means k 7q plus q, radius is outside point, so 2r radius. See, that equal to here potential on B due to 2q minus q. What na here? K 2q minus q, radius is here 2r. Radius is 2r. See, potential on B due to 7q plus q. What na here? K 7q plus q by 2r. See here, all have r, we can cancel. See, k also cancel. Why? Because all are having. See, now what we have now here, 2q minus q plus 7q plus q by 2, that equal to 2q minus q by 2 plus 7q plus q by 2. Yes, na? See here LCM na, it will take here 2 into 2, 4q minus 2q by, we can write 2 later, 7q plus q by 2, that equal to here LCM na, denominator same, just added 2q minus q plus 7q plus q by 2. This two cancel. What now here? See, minus q plus q cancel. What we get here? 4q plus 7q, 11q minus 2q plus q means minus q, that equal to here 7 plus 2, 9q. See, 9q. See here, 11, this will be changes to here 11q minus 9q equal to q. 11q minus 9q means 2q that equal to q. What is the charge on, what is the charge is transferred from surface A to surface B na 2q charge. See again listen, what is the problem now here? Two concentric cells connected through conducting wire. Then find the potential on each surface. For that, these two conductor will be connected by conducting wire. These concentric cells be connected by conducting wire. See, first on charge is 2q, second on charge is 7q. Due to connection, what happened here? Some charge will be transferred from inside surface to outside surface. So that is q charge is transferred. What is the charge is transferred? We don't know. We consider q charge is transferred. That's why it loses charge 2q minus small q. It gains charge 7q plus q. So whenever charge is transferred, means both are connected from center to surface. It maintains same potential. That's why we can take potential on A equal to potential on B. So what is potential on A now? Potential on A due to 2q minus q. Potential on A due to 7q plus q. Potential on B due to 2q minus q and 7q plus q both. See here potential on A due to this one means on surface, due to this one outside point. Potential on B due to this inside point, due to this on surface. So we can write here potential due to this one 2q minus q, it is on surface radius r. Due to this point means k 7q plus q, radius is 2r. So potential on B due to this one radius is 2r we can take. Why? Because it is here we find out the potential on outer means second surface we can find out. See due to this one, so k 7q plus q by 2r. See r common, all have, so cancel. K also common, so cancel. So all are having, so cancel. What we get? 2q minus q plus 7q plus q, 2q minus q by 2, here 7q plus q by 2. See here, so LCM 2 into 2q, 4q, 2 into q, 2q, 7q plus q. Here denominator same, just numerator added 2q minus q, 7q minus plus q by 2, q cancel. What we get now here? 4q plus 7, 11q, 2q plus q minus 2q plus q minus q, that equal to 7 plus 2 9q. See 9q changes to here 11 minus 9 equal to q. 11 minus 9 means 2q, that equal to q. What is the charge on? Charge is transferred while connecting the concentric cells with the conducting wire na q equal to 2q. What is the charge now here? See once here small q is 2q now. What we can write here? 2q minus 2q, 0 charge here. So 7q plus 2q, 9q means after connecting the conducting wire on surface A, charge is 0, on surface B, charge is 9q. Means when concentric cells are connected through conducting wire, whatever the charge on the inside surface totally transferred to outside surface. Why? Because already we have condition all conducting cells or spheres charge is always resides on surface. That's why here whatever the charge here, it will be transferred to surface. Yes na? This one. See next we discuss about conducting cells, how to charge distributed on inside surface, outside surface, that we discuss. See conducting cells. Yes na? Next is conducting cells. In this one, see nothing but here thin cells. Thin cells charge distribution. Charge is distributed on inner and outer surfaces. Inner surface and outer surface. Outer surface. Now see here what we can do now here. Thin shell na, this one. See, this is the thin shell. Means here it is the thickness. It is thickness. Yes, na? See, it is the thickness. See here how to charge is distributed on inner and outer surfaces. It is the shell. So it has thickness is there. See here charge is inside is there. How to charge is distributed inside surface, outside surface. For that, one important point is note what now here electric field inside the metallic conductor is always zero under electrostatic condition. See electric field. See electric field inside the conductor, inside the metallic conductor, material of conductor means material of conductor under electrostatic condition, under electrostatic condition, under electrostatic condition, under electrostatic condition electric field inside the material of conductor is zero under electrostatic condition. Means see here inside material electric field is always zero under electrostatic condition, but here charge is there. So charge is provides electric field lines inside. Means here not material, it is a hollow sphere. So that's why here from here to here transferred. See for that what we can do now here, we can surface, we can select Gaussian surface. So means Gaussian surface according to Gauss law, according to Gauss law what now electric field inside the Gaussian surface is zero, inside the Gaussian surface is zero. So here see that means this is material of the conductor. So material of conductor inside is zero. That's why what we can do now here now, see inside charge also do zero. That's why we can write here plus q charge is there, here we can write minus q charge. See I write here how to charge distribution now. It is the cell, it is the cell. See here we can select Gaussian surface. When select Gaussian surface now, inside the Gaussian surface electric field is zero for conducting cells, for conducting cells. Why? Because charge will be total will be resides on surface of the sphere. So that's why see due to Gaussian surface we can select Gaussian surface now. See inside electric field is zero, inside electric field is zero, q also zero, charge inside the charge is zero. See here, here q charge is there, when it is zero here we can add minus q. So here minus q add now, it is the Gaussian surface. According to Gauss law electric field inside the Gaussian surface is zero for conducting cells. See here minus q, here we can add plus q. Why now here minus q plus q zero inside the Gaussian surface electric, electric field is zero. So plus q, so plus q minus q again zero. What is the charge on this one? Zero only. Yes na? So inside material of the conductor is zero. So here plus q means here minus q, minus q na, here we can write plus q. See like this charge will be distributed on surface, inside surface or outside surface. See here this minus q plus q again cancel, zero only. Here minus q plus q, here zero only. Yes na? See charge is here, q is there, again we can get same. So like this charge distribution takes place. See here is minus q, here plus q. Why now minus q plus q again gets cancelled. So here plus q is there, automatically here minus q. So this minus q now here we can add plus q. See plus q, see plus q minus q again cancel, what we can charge is zero. So what we have charge is q, this charge will be distributed inside surface. So I write here, see charge will be distributed, here charge q is there minus q in this surface, here see here plus q, here minus q, here plus q. Like this charge will be distributed inside the surface, outside the surface. Yes na? See once here, conducting cells in means thin cells. What na condition? Charge is distributed on inside surface, outside surface. So what is the condition na here? Electric field inside the material of conductor is 0 under electrostatic condition. Under electrostatic condition, inside material of conductor, electric field is always 0 under electrostatic condition. Not here. Here plus q charge is there. Due to this, electric field lines are coming this one. So for this electric field lines becomes 0 when it is now. For that, what we can select? Gaussian surface. Here we can keep minus q now. Electric field lines moving here like this now. It means what is the charge inside the sphere? 0. So here plus q. So with plus q now, here we can write minus q. So means minus q is there in this surface inside. The outside now plus q. So like this charge distribution takes place. But finally, what we are getting now? Q only. See here, minus q plus q cancel, minus q plus q cancel. What here? 0, here 0. What we have? Q only. But so how to charge distribution are this one? For example, see here, it is the sphere, first one. Here charge is q, here minus q, minus 2q. Here now second sphere now, here see 3q is there. How to charge distribution takes place now? Here q is there. See I write here, see q. Here q na minus q we can write here. Here minus 2q is there. Here minus q we can add. So we can write here plus q. So minus q, minus 2q plus q. What we get? Minus q only is there. Here minus q. Next here minus q. Minus q means here we can write plus q. So plus q na, here we can write minus q. Here minus q, here plus q we can write. Here minus q na, plus minus q we can write. Now see here, see minus q 2q, sorry, here 3q is there na, 3q minus q we can write. What we get now? Here see, finally, here I write finally what distribution is there. Here right now it is, here c q, here minus q, here minus q, here see, here minus q now, here plus q, here 2q is there. See once. So this q minus 2q 3q, how distribute now? Inside q is there, inner surface minus q, outer surface for this now minus q, this one plus q, here 2q. Well again add now q here, minus q 2q, here plus q and 2q 3q. In this surface 3q is there, in this surface 2q is there, here q is there. So but this charge distribution will be like this happen. See q minus q minus q plus q minus q plus q, here 3q minus q 2q. See here na, for according to Gauss law, inside Gaussian surface is charge is 0. For that we can write here minus q plus q 0. Yes na? Here minus q add means here plus q. So plus q means already 2q is there, minus 2q. So means minus q we get. Minus q na, here we can this surface 0 we can take it 0. That's why plus q minus q 0 here. Here plus q add na, so automatically here minus q we can add. So here minus q is there, for 0 doing 0 this one. See what na, here plus q added. So here plus q na, here minus q. Already 3q is there. 3q minus q 2q. See this q minus 2q plus 3q. How to distribute na? Q minus q plus q 2q. So minus q 2q we get same. Here plus q 2q 3q. So means this q minus 2q plus 3q, how to distribute na? Like this it's distributed on inner and outer surfaces. Inner and outer surfaces. Next see one more. See it is the first sphere, charge is here q. Second sphere, see here charge is minus 3q. Another sphere here, see here now, here minus, sorry, 2q, here 2 small q, here q. Like this is their charge. How it will be distributed on surface of outer surface, that's not that we discuss. See here this one, see first one q. So now q now, here we can write minus q, so this charge is 0. So in this one minus q is there, see here, in this one minus 3q is there, here minus q added, so means here plus q. So minus 3q plus q means minus 2q, minus 2q means here plus 2q we can write. Here what is there, here plus 2q is there, see here plus 2q, here we can write plus 2q is there, minus 2q we can add. Why not, here plus 2q added here, so minus 2q. Here what we get is 0, here is 0. What now, here q. See here again once, it is the charge q. What we can do, minus q, so means this 2 0. So here minus q added means here plus q, already minus 3q is there, minus 3q plus q minus 2q, minus 2q means I write here minus 2q. So minus 2q is there for zeroing this, so plus q plus 2q we can add, plus 2q here add means minus 2q subtracted, here already plus 2q is there, plus 2q minus 2q 0. So means here 0 charge means here 0, so plus q is there, means this will be how distributed. Now here see I write here, this is the small sphere, next one, next one, see here how it will distribute, q now, q minus q, here minus 2q, here plus 2q, here 0, here 0, here q. See here minus q 2q, how much, minus 3q we get. See plus 2q 0, plus 2q we get, so 0q we get 0. So means in this surface minus 3q, in this surface 2q q, so this 3q is distributed minus q 2q, inner is minus q, outer is minus 2q. This 2q is distributed, inner is plus 2q, outer 0. So here q is distributed, here 0 q we can add, we get the same, this one. Like this charge is distributed, inner surface, outer surface. For example, see one more problem, see see this is the sphere, it has q, here see one more sphere, it is one more, here is 2q, here 4q, here 6q. Now see charge distribution how takes place here, inner and outer surfaces. See here first one, second one, so third one, here see three spheres is there. See first one q, here q, here we can write minus q, already 2q is there, 2q means here minus q is there, plus q, what we get, 3q, 3q means here we can add minus 3q, here 4q is there, 4q is there, minus 3q means plus 3q, here means what we get, 7q. So 7q now, here minus 7q, so minus 7q means here 6q is there, 6 minus 7q we get minus q. So this one, so like this distributed. See what is distribution, after distribution I write here first one q minus q, second one see what, 3q minus 3q, third one, see third one, see 7q minus 7q, here minus q. See here now, see added na, sorry something, here 7q plus q, 7q minus 7q plus 7q, here sorry this one is 13q, here what, 13q. See now, see here q minus q, then it is Gaussian surface we can select now, here it will 0, it's na 3q, here minus 3q we can now, here we can select Gaussian surface, this will be 0. See here minus 3q here na, so we can add plus 3q, plus 3 plus 4 7q, so means here 7q is there, means minus 7q we can add, then it will be 0. So 7q now, here plus 7q we can add, 6 already is there, 6 plus 7 13q. So like this it distributes. So q minus q plus 3q minus 3q, 7q minus 3q, 7q. Now we can add now, here see 3 minus q, so what, 2q, here see 7 minus 3q, 4q, here 13 minus 7q, 6q. So means this 2q, 4q, 6q will be distributed, inner surface, outer surface, like this it will be distributed, like this charge will be distributed inside and outside surfaces in conducting cells. In conducting cells means thin cells. See last one problem. See cells three conducting cells three conducting concentric cells three conducting three conducting concentric cells three conducting concentric cells. Cell B is earthing, shell B is earthing, shell B is earthing. Show charge distribution, charge distribution on each cell, each cell. Let charge on shell B, shell B be capital Q, shall be capital Q. This case we want to find out how the charge is distributed, how the charge is distributed. See three cells. See here I write here three cells. It is the first cell, yeah, it is the second cell, it is the third shell. See I write here, see what now, shell B is earthing, it is earthing, yes na. See this radius is r, this radius is 2r, this radius is 3r. Here is charge is q, here charge is 2q, here charge is capital Q, charge is capital Q. So this three conducting concentric cells, cell B is earthing. Show charge distribution on each cell. Let charge on the cell B be capital Q. First we find out what is the charge, sorry, first we find out what context is. Cell B is earthing, so LB is earthing now. What is the here charge we find out. See first here, so means potential on B, what now here earthing na 0, potential on B due to this one and due to this one and due to this one. See I write here potential on B due to small q, potential on B due to second surface means capital Q, potential on B due to 2q, due to 2q. Alright, here potential on B 0. Why? Because earthing. See here due to q, due to q means it is inside point, yes na. Due to capital Q means on surface, due to 2q means outside point, outside point. See here potential on B due to q, k q by what na here radius r, yes na. See plus potential on B due to q, k capital Q by on surface na here 2r. Why na here see it is the this surface we are finding from here to here potential is same, that's why kq by radius this we can take 2r. See potential on B due to q on surface 2r, potential on B due to 2q surface is 3r, yes na. Here 0. See here r r common and send to this side na. So what we get, k k common and send to this side, what we get 0 equal to q by 2 plus q by 2 plus 2q by 3. See LCM na here, see these two added, yes na. This 3q here 2 2 4q means 3 plus 4 7q. So 7q by 3 2 just 6. Here q by 2, yes na, it will be changes to 0 now. So totally what equal to 0. So we can write here 7q by 6 plus q by 2. So means 7q by 6 equal to minus q by 2. So means here 2 ones 2 threes means capital Q equal to what we can write 7q by minus 7q by 3. It is the charge on shell B. After this, how the charge is distributed, that also we can write it here. See, it is first one, second one, and third one. See here, I write now one by one. First one, q is their charge. Charge is q is there. Second one, minus 7q by 3. Third one, 2q. Here see, here no, nothing, no charge is there, so no issue. Here see, minus q we can write. What? How charge distribution are here, minus q, then these two will be 0. So here minus q means here plus q we can add. So means 7q by 3 plus 3 plus q means 3q minus plus 3q minus 7q means 4q by 3 minus 4q by 3 here resultant. Here minus 4q by 3 means here we can plus added 4q by 3. Here plus 4q by 3 means here minus 4q by 3. So what is the resultant? 3 2 jar 6, 6 minus 4, so means 2q by 3. It is the charge distribution here. See, again I write here. After that, see, this is the first cell, second cell, and third cell. See, first cell no charge, so here q minus q, here minus 4q by 3, here plus 4q by 3, here 2q by 3. Like this charge distribution takes place. See here, q na minus q we can add. So 4q by 3 minus q means 3q, 3 plus 4 7, 7 q by 3 we get, 7q by 3 we get. Here 7q by 3 na, here 2q by 3 plus 4q by 3, 2 plus 4 6, 6 by 3 2 we get, 2q we get. Yes na? So this charge q minus 7q by 3, 2q by 2q, how distribute na? Q minus 4q by 3 plus 4q by 3, 2q by 3. So 2q by 3. Like this charge is distributed inside outside surfaces on conducting cells, conducting thin cells. So this is the potential in concentric cells. Okay, thank you. See, please see my videos and subscribe the channel and share to your friends. So please subscribe my channel. Thank you.